Good morning. Here's a video to go over our 9E notes. We're just solving exponential equations here with a variable in the exponent. We're going to get to this more in the next unit, but just to sort of introduce ourselves to it here. So the property of equality of exponential equation states that if b is a positive number other than 1, if b to the x power equals b to the y power, if and only if x equals y. Okay? So largely put, if we had 2 to the x power is equal to 2 to the 7th power, then x would have to equal 7. That's all this is really saying. It's pretty simple stuff. So on this first example here, if we have 25 to the 2x plus 3 power is equal to 25 to the 5x minus 9 power, we can make 2x plus 3 equal to 5x minus 9. And we go to solve it, we'll move the x's over to one side and get them by itself. So, we'd minus 2x here, minus 2x there. So we end up with 3 equals 3x minus 9. There, and we plus 9 and divide by 3. So we end up with 12 equals 3x and x equals 4. Just a simple algebra equation. All right. It gets a little bit more complex when we don't have the same bases, but if we have the ability to change the bases, then we're going to sort of do that. Okay. I want to start over here on this one on the right first. So here we have 9 to the 8x minus 4 power equals 81 to the 3x plus 6 power. And what we need to do in order to solve these, we need to equate the bases. The bases got to be the same, okay? Now, in order for them to be the same, we need to sort of think in terms of exponents and powers here. So here we have a base of 9 and a base of 81. What we can do is we could simply take the 81 and change that to 9 squared. So we have 9 squared to the 3x plus 6 power. Okay. And then we equate this to 9 8x minus 4. And now we see that the bases are equivalent. We have 9 and 9. So because the bases are equivalent, we can equivalate the exponents. Okay, so we have 8x minus 4 over here. And now we have 2 because we had to make the 81 9 squared. So we have 2 times 3x minus 6, or plus 6. All right, so coming around here, we have 8x minus 4 is equal to 6x plus 12. Move the 6x over, so we have 2x minus 4 equals 12. And then 2x equals 12 plus 4 is just 16, and x is equal to 8. All right. But the key is we have to equate the bases, and that's what gets kind of tricky. Especially when we get down here a little bit. So we have to sort of think of square roots or cube roots or numbers to where we can get kind of the same base. And there's more than one right way to do these, but I kind of like to look at the either the square root or the cube root. It's probably the best way, depending on what we have. So if we come over here, 4 to the x power equals 1/2 x minus 3, okay? This is a little tricky, but here we know 4 is 2 squared. So what we'll do is we'll do 2 squared to the x power. 1/2 also has a base of 2 because it's 2 to the negative first power. Okay, so we change the 4 to 2 squared, and we change the 1/2 to 2 to the negative first. Okay, so since they both have 2, so what we're going to do is we can take the exponents and equate them. So we'll take the exponent here of 2x, and we're going to equate that to negative 1 times x minus 3. So 2x equals negative 1 times x minus 3. And then we can go and solve that from there. You can always, if you want to, go into Desmos and check them out and sort of graph one side, graph the other side, and find the x where they equal. That's always a quickie way to sort of check your work too. But if you were to do it algebraically, we'd have to change the bases sort of like this. Okay. I'm not going to go over the rest of this, as we should be able to solve this out. Just basic algebra skills here. So 3 examples. I just want to set these 3 up on the bottom here just to make sure that we're good. If you feel good about these already, then by all means go on to the practice problem in the back. All right. So we have 9 and 27. Okay. 9 and 27. We know that 3 multiplies into both of those. So we know the 9 is 3 squared. So we can make that 3 squared to the 2x power. (27) is 3 cubed. So we can make that 3 cubed to the x minus 1 power. So if we have 2 to the 2 times 2x there, so we have 4x here, can equal 3 parentheses x minus 1 there. Okay, here we have 100 and 1,000. Okay, well, what number kind of multiplies into 100 and multiplies into 1,000? That could be a root of either one. Well, the answer there would be 10. So 100 is 10 squared. So 10 squared times 7x plus 1. I'm going to write the other one underneath here. And then 1,000 is 10 cubed. So that could be 10 cubed, 3x minus 2. So now we set both of our bases of 10. And now one side, our exponent is 2 times 7x plus 1. On the other side, we have 3 times 3x minus 2. From there, we can hammer out the math and solve that out. All right, last one, we have 81 and we have 1/3. Again, this is probably going to take a little bit of finesse, and there's more than one right answer to do this. There's more than one right answer to do this, but with 81 we know is going to be 3 to the 4th power. And we're going to have 3 minus x. Over on the other side, 1/3 is 3 to the negative 1st power. 3 to the negative 1st power, and then 5x minus 6. So what we'll have here is we'll have 4 times 3 minus x equals negative 1 times 5x plus 6. Okay, So we need to just use our rules of exponents to sort of change these bases up a little bit in order to get what we are looking for, because once the bases are equated and we exponentialize them accordingly, then we can equate the exponents to each other. All right. We could always check our answers in Desmos. So let's just say hypothetically we want to check this first one out. 9 to the 2x power and then 27 to the x minus 1 power. Let's go ahead and try that. So we have y equals 9 to the 2x power. And the other one we have 27 to the x minus 1 power. If we do the math, we should have gotten to -3. And that's where both of these graphs are going to meet at, -3, 0. And that's it. So get on that, and you guys have a good one.